for repeated quadratic factors, but it's more than that. It's all-inclusive case. So you may have linear factor, repeated linear factor, non-repeated quadratic factor, and a quadratic factor, or more than one quadratic factors in this case. So let's say Q of x has a factor in the form of ax squared plus bx plus c raised to the power of r. Again, b squared minus 4ac, the discriminant is negative. Okay? In this case, we can write the function as a sum. Right. In this case, we write the integrand as a sum. I can say that the following sum, a1 x plus b1 over ax squared plus bx plus c, then plus a2x plus b2 over ax squared plus bx plus c squared. And then we keep writing coefficients like this until we reach the last one, which is the r term, which with the factor ax squared plus bx plus c raised to the rth power, r being the highest power of this particular quadratic factor. Okay? So this is the general structure. And quick example here, we call it example 7. We're going to write as a sum of partial fraction. We want to write x cubed plus x squared plus 1 over, here we have x times x minus 1 times x squared plus x plus 1 times x squared plus 1 cubed. So here's really an all-inclusive kind of deal here. You have a linear factor x, a linear factor x minus 1, non-repeated quadratic x squared plus x plus 1, and repeated quadratic x squared plus 1. So the solution going to be like so. We're going to say that this one equal to a over x, the first linear factor, and then the next linear factor, b over x minus 1. Here comes the first quadratic factor. We need to have cx plus d for quadratic. And the first quadratic factor is x squared plus x plus 1. And then we have 3 repeated quadratic factors, right? So first one will be ex plus f x squared plus 1. The next one will be, what comes after f? G x plus h over x plus 1 squared, right? And then lastly, we have ix plus j x squared plus 1 cubed. Okay?